Hello, ladies. Today we're going to be endeavoring into 11-2, which is the area of circles and sectors. When we talk about sectors, we don't mean like a sect. We mean like a section of our circle. Giving you a heads up, the more common type of circle we're dealing with today is going to be sectors of circles. And the reason why is because in the real world, you actually typically don't deal with circular objects. You deal with a part of a circle, because you typically are given, like, for instance, like the most common circle we can think of is probably like a pizza. Once the pizza is given to you, it's already in its pie. Then we take away a slice and boom, we now have 7/8. We want to find the area of those 7 slices. That's what we're looking at, really. So before we go into some problems, we need to go over some circle basics. The area formula of a circle that we're going to first look at is pi r squared. Pi r squared. So this is the first formula we're going to be looking at. Their circumference is 2 pi r, or pi times your diameter. The area inside the blue chain of your circle is known as the area of our circle. So everything on the inside is our area. The length of the blue path along the line, so for instance, inside is our area. Outside is our circumference. And circumference is a fancy way of saying perimeter. The reason why we say circumference is because circles don't really have side lengths. It's just an object that we can measure around. All right, so these are formulas that you have to memorize. So our first example, this is a question that I took from the Regents. It says, to the nearest tenth, find the circumference and the area. So the first thing we're going to do is we're going to find our circumference. We know that circumference is equal to pi times your diameter. My diameter is 22.6. And I just type this into my calculator, pi times 22.6. And I get my circumference to be 71.0 meters. That is your final answer for your circumference. Again, it's just number chugging. Now my area, I'll do in red. Area equals pi r squared. Here's the issue. I don't know what my radius is. I have a diameter. So to find your radius, you take your diameter and divide by 2. So I do 22.6 divided by 2, which gives me 11.3. So my radius is 11.3. So I now plug it into my formula. So area equals pi times my radius of 11.3 squared. I type it into my calculator, and I get my area to be 401.1 meters squared. So that's her final answer for that question. My circumference is 71.0 meters, and my area is 401.1 meters squared. Now we're going to go on to the next example, where we have to find the area of a circle whose circumference is 28.3 kilometers to the nearest tenth. So the first thing we're going to do is we're going to write down the area formula. So area equals pi r squared. I'm going to substitute in my radius. So it equals pi, oh wait, I don't know what my radius is. But here's what I do know. I know my circumference is 28.3, so I actually just solve for my radius. So circumference equals 2 pi r. You could do pi d, but I'm just giving you a heads up. Since you want your radius, I would use the equation that has your radius. I know that 28.3 equals 2 pi r. Divide both sides by 2 pi, because 2 pi is a number. And I get my radius is close to 4.5. I now take that number, and I substitute. So I end up getting area equals pi times 4.5 squared, which is approximately 63.6 kilometers squared. That is how you approach these problems always. Okay. Now for that next example. We're actually going to be traveling backwards. We want to find their circumference, whose area is equal to 12.6 centimeters squared. So I write down my circumference formula. Circumference equals 2 pi r. I now do circumference equals 2 pi times my radius, but here's the issue. I don't know what my radius is, I only know what my area is. So, we know area equals pi r squared. We can substitute a 12.6 in for our area, and we can use this to solve for r. I divide both sides by pi, because pi is a number, it's not a variable. My pi's cancel. And then I get r squared equals 12.6 over pi. The only way to get rid of a square in math is to take the square root. So I end up getting r equals, if you type this into your calculator, you should be getting close to 2. So I now plug this 2 in, and I get my circumference to be 2 pi times 2, which I just type into my calculator, and I get 12.6 centimeters. That is your final answer. So those are the level of difficulty you should do for general circles. That is the hardest level to get for a general circle. Now we're going to look at sectors of circles. So the sector of a circle is a part of a circle formed by 2 radii and the circumference. I'm just reading the top part of the video. It looks like a pie piece. Often we are asked to calculate circle sectors, whether it be half a circle, a semicircle, or a quarter of a circle. These divisions are rather easy to visualize and calculate. If you want to calculate the area of a semicircle, you divide the area by 2, or in this case of a quarter, you divide by a 4. It becomes more difficult if the sector has, say, a 49-degree angle. So what do you divide by now? So we know that there are 360 degrees in a circle. But when I look at a semicircle, I'm really only caring about 180 degrees. So if I want to find the area of a semicircle, I just do 180 divided by 360, half. So in this case, if I have 4s, this is a 90-degree angle. I just do 90 over 360 and I get 1/4. And then I just keep on doing my angle divided by 360. So your regular sector of a circle formula that you have to memorize is x over 360 pi r squared. And that x is just the measure of your central angle, or the angle that opens up and hits your outer piece. All right? Let's do some sector problems. Find the area of a sector in terms of pi. So whenever it says in terms of pi, you actually have a pi in your final answer. We don't want to type the pi key on your calculator. Okay? So for this example, I have a central angle of 240 degrees. I have a radius of 15. And I want to find the area of this sector. So I'm going to draw in a little. I want to find the area of this piece, okay? So if I want to find the area of a sector of a circle, I just use this formula. Area equals x over 360 pi r squared. I know that my x is my angle, so I get area equals 240 over 360 pi times my radius of 15 squared. You type in everything in your calculator, the 240 over 360 times 15 squared. The only thing you don't type is this pi. Don't type. After I type this into my calculator, I should get 150. And now I write the number pi. That is your final answer. 150 pi centimeters squared. If you want, what you can do is if you're like, oh, I completely understand how to do this problem, go on to the next part. Do the next question by yourself. So with the exact same procedure, we want to find the area of the sector of a circle. So my formula we did before was area equals x over 360 pi r squared. Our angle is 315. And it's over 360. My pi stays the same, and my radius is 7. And I square it. I just type the numbers in my calculator. I don't type the pi. And I get 42.875 pi. If you're doing a scientific calculator, if you're typing it on Desmos and you type it in exactly as it's written, or in a graphing calculator, you might even get a fraction, which is fine. You can also write it as area equals 343 pi over 8. And my units are kilometers squared. That is your final answer. Now for these two examples, it says find the area of the sector to the nearest tenth. So in this case, I actually do not want a pi in my final answer. So I do the exact same procedure, but this time I actually type everything into my calculator. We know our sector formula is area equals x over 360 pi r squared. My angle is 135. I write my pi, and I write my radius of 17, and I square it. We type this exactly into our calculator as written, and you should get 340.5. meters squared. And that's your final answer. If I were you, I would definitely try to do the next example by yourself because it is exactly just like the one we just did. So, I'm zooming in, do it by yourself, hit pause, whatever, or you can follow along. Our formula is again area equals x over 360 pi r squared. I know my angle is 45 degrees. My radius is 5. And I just type it into my calculator. I should get 9.8 miles squared. And that's your final answer. If you have any questions, make sure that you email myself or Miss Kimmick. Make sure you write your daily question on the classroom. That way we can capture your attendance. Overall, this was a relatively doable lesson. It's mainly just substituting your radius and your angle measure into the formula. You're never going to be asked, at least I haven't seen on the Regents, knock on wood, I've never seen them say, oh, what's the angle that has an area like this? That would be a nice challenge question. But overall, this is the level of difficulty you should be expected to do for finding the area of a sector of a circle or a section of a circle. If you have any questions, please email me, but do not forget to write your daily question. All right, have a great day, ladies.